Hello, everyone. Good evening. Dear authors and invited guests, welcome to Technical Session 8A. Myself, Ishita Soran, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event is being held through Zoom today and was held yesterday, that is 21st and 22nd February 2024. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we'll have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for question and answer. On 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to the chair for this session. We have with us session chair, Dr. Yashwant Dongre, who is currently working as an assistant professor, Vishwakarma Institute of Information Technology, Pune, India. Researcher in the field of service computing and AI, he's excellent in development J2EE-based applications capable of handling databases and web servers, that is Apache, JBoss. He's exceptionally well in Java, JSP, and AGB coding. We welcome you, sir. We'll be proceeding with our...
Thank you for invitation and welcoming me.
Thank you, sir. We'll be proceeding with our paper presenter. I'd like to invite the first presenter of the evening, Emmanuel, with the paper titled Automated Transcription of MTM Motions in a Virtual Environment. You may start your presentation, sir.
Yes, sure.
Can you hear me?
Yeah, you're audible.
Perfect. Let me 1 second start my screen. Can you see my screen?
Not yet. You haven't shared it yet, I believe.
1 second.
Yeah, it is visible now. Please go ahead.
Just give me 1 second because I think it's the wrong screen.
The motivation slide is currently on.
Can you see my screen now?
Yeah, it is visible. Please go ahead.
Perfect. So, hello everyone. Sorry for the delay. My name is Emmanuel Andreopoulos, and today I'm going to share with you the work that we developed at ETH Zurich on the automated transcription of MTM motions in a virtual environment. Let's start with some motivation. This paper is inspired by the topic of manual workplace optimization. This involves the optimal design of the workplace as a whole and the optimal placement of all the tools and the equipment needed to perform the workflow. Traditionally, this process, my apologies. My apologies, I have some system problems. Yes. So traditionally, this process starts with the setup of the workplace, either through cardboard mockups or the real equipment. And then the tasks are performed by the workers as designed. This process is transcribed, is recorded and then transcribed by experts in a manual transcription way using standardized time measurement systems. Method time measurement, or MTM, is one of the most widely used such standardized time measurement system, using the so-called time measurement units to map certain actions that the user is taking with standardized time measurement actions. For reference, 1 TMU is equivalent to 0.03 seconds, 0.36 seconds of action. Methods time measurement is a family of standards and has several different standards which give a different detail on the evaluation process and are based on the nature of the workplace that is being evaluated. In our work, we consider the so-called MTM2 standard, which is the second most thorough evaluation system of MTM. Apart from this wide adoption in the workplace evaluation process, MTM is also VR and mixed reality friendly, since we don't consider the time of the actions, but only the actions that are taken during our workplace process. However, this process traditionally requires the video of the work process being recorded, which is then automatically transcribed by an MTM expert, which is a process that is both time-consuming and expensive. In order to alleviate some of these disadvantages, an alternative approach would be to move the MTM analysis in virtual reality. This would allow us to have a wide range of virtual environments without the cost and the extra waste that cardboard mockups or the actual components would involve in the process, and also allowing us to have small changes on the go. However, moving to virtual reality would come also with a reduction of haptic sensation and weightless objects, which would not be a very big problem, especially in the early stages of the evaluation process. There is some work that has been done towards this direction, which, however, is not very well represented in literature. The two most important pieces of work are from Bellarbi et al. And Benter et al., which are presented in this slide. The first is a decision tree-based approach, which uses an head-mounted display and two hand controllers, and the so-called MTM UAS system, which is not a very detailed system of MTM. This uses a decision tree-based algorithm which creates sequences of data such as accelerations and rotations, which are tracked and then compared to specified expected values. On the other hand, the second work from Benter et al. On the classification of the MTM1 actions through characteristic parameter sequences uses Microsoft Kinect to track the user, and through a three-step identification process, it creates the identification of the MTM1 actions. Both of these pieces of work, however, come with certain disadvantages which are reported in the papers by the authors, which either because of the sensors that are used or because of the algorithms that are used, they don't create a very high performance in the evaluation process. Let's now continue with with the equipment that we use in our methodology. This is the HTC Vive Pro headset, the two controllers, as well as three HTC Vive trackers. These are placed on the user as we see in this slide, creating a 6-point tracking system with the two controllers placed at the hand, two Vive trackers placed on the feet of the users, one at the back, which are all equipment that are used to create the data set, to extract the data, both rotational and positional data that we use for our algorithms, and the headset, which is used to immerse the user in the virtual environment. Through this 6-point tracking system, apart from having the data that we need for our algorithms, it also allows us to create an animation, a full body animation of the user using a virtual avatar. For this, we use the Make Human open source software platform, which allows us to depict the user in the virtual environment using the virtual avatar that is shown in this slide, and also the final IK algorithm in order to perform the inverse kinematics calculations needed to actually track the user in real time. Now, the main piece of work that we create in this project is the transcription algorithm. This is a real-time detection algorithm which allows simultaneous classification of different motions, such as grasping and stepping at the real time. And the MTM2 actions that are considered from our algorithm are the full body actions, step, foot motion, and bend and arise, as well as the hand actions, get, put, regrasp, and apply pressure. The actions that were not considered are eye actions and trunk, since we didn't have the time to process these two actions. Because we don't have much time in this presentation, I'm not going to go into detail of the transcription algorithm process, which, however, can then be looked upon at our paper that is accompanying this presentation. The transcription algorithm that we developed was evaluated through a user study that had 30 participants and used a custom virtual environment, which is shown in this slide. This, 1 second. The Zoom is creating problems again. 1 second. Yes. So, as can be seen in this video, in this slide, which hopefully it plays, yes, you can see here that through the animation of the body using the virtual avatar, we can see what the user is doing in the virtual environment in real time without having to actually see the users themselves. And also, it allows us to evaluate the transcription algorithm that's developed through the user interface that we see in this UI that Unity is giving us, which is interfacing with the transcription algorithm and shows us in real time what actions are predicted. Through this process, we can both evaluate the transcription process, and we have an final version of the MTM workflow, which without having to see the user themselves, and we by automating the process as well. Through this process, during the user studies that were undertaken, we took the data, which were then post-processed in order to result to the true positives, false positives, and false negative actions, which further we use to calculate the precision and recall for all the predicted actions. Precision gives us, out of the true positives, out of the true actions, how many were actually predicted by the algorithm, while recall shows us how many of the predicted actions are actually relevant. As can be seen in these tables, most of the actions were predicted with both precision and recall being more than 90%, which shows a remarkable potential of the algorithm that was developed. Finally, I would like to conclude with the contributions of the work. In the core, we have the algorithm to automatically transcribe the main MTM2 motions in virtual reality. And at the same time, we combine this with a feature of full body animation through a virtual avatar, which allows us to see the user actions, and evaluate the whole process. A user study was undertaken, which was attended by 30 participants, which further showed the potential of the algorithms that were developed in this project. Also, the user study recording setup that we just saw in the video allows us to visualize the transcription process in real time and could provide an alternative to the currently established traditional process of video recording and then a manual transcription by the MTM experts. Thank you very much for your attention.
Thank you, sir. We'll be taking questions.
Yeah.
Yeah.
Hello, Emmanuel.
Hello.
Hello. Yeah, presentation is nice, and concept is very novel. I just want to ask you, Because you use term optimization algorithm or optimization. So that in virtual reality, in the case of virtual reality, do you think it is a need of the optimization in terms of heuristic or meta heuristic? The problems are solvable in a time, or they are NP hard problem. Which type of problem you are going to solve?
I'm not really sure
Are
if
you
I
getting my
understand the
question?
question. No, I'm not 100% sure if I understand it correctly. Which
Okay.
sort of problem we are targeting to? The optimization that I'm talking
Yeah.
about in
Yeah.
my presentation is
Yeah.
optimization of the workplace, which is currently
Yeah.
done with with standardized time measurement systems such as MTM that I presented. But it's not an automatic optimization problem that is solved through a mathematical process. It's a manual process which is using these standardized time measurement systems, and then experts who are trained based on these processes, they assess how optimal the workplace is. And what we are suggesting is essentially, instead of having this manual work of transcribing the actions using a video of the process, we move the whole process in virtual reality. And through using sensors and computational algorithms, we can automate the transcription process of the actions. And then essentially we can have a final cost of and time cost through our TMUs, the time measurement units, of how optimal the workplace is with the current setup. Then we can iterate through this process and change the position of the objects, the position of the equipment, redo the evaluation process, and then like that we can create a more optimal workplace without having all the manual labor. Do you understand what I mean?
Yeah, I got it.
Perfect.
Even it is again in virtual reality, problems are more dynamic and values are often changing. So that how you are cope up with this optimization algorithm again.
Yeah. So in general, it's not what we developed because it's based primarily on heuristics. And it's not really using any deep learning or machine learning algorithms to do in real time the transcription process. It's very fast and it's not very computationally intensive. This allows us to maintain a good frame rate in virtual reality and at the same time have the algorithms running on the background without affecting the frame rate or the experience of the user. And resulting to the automatic transcriptions that I mentioned. And yeah, I would say that the main way of avoiding extra delays because we use virtual reality is that we go with heuristic processes that are well researched, and we follow certain thresholds that are experimentally proven to avoid having to perform transcription through deep learning inference or things like these that would really delay the process and drop the frame rate of the whole experience.
Okay, I got it. Then last issue. Then if problem is going to increase larger and larger, then how meta heuristic will come in the place?
Can you explain me what you mean by meta heuristic?
These are you are talking about heuristic. They are problem specific, and you are correct. And if you are going with meta heuristic, they are general. They will not be a problem specific. If problem space is larger, then we are going with meta heuristic. So that how
I see
your
what you mean,
problem,
to generalize.
yeah.
How to generalize. I mean, we're targeting here a very specific problem, and we're trying to solve essentially the optimization of manual workplaces, which are based on certain standardized systems that have very specific actions. So it's not a problem that would really need a generalizable approach. And that's why we don't go towards that direction. If we, of course, then if we try to solve more problems which have higher uncertainty or a bigger space of predictions, we would not go with such an approach, and then we would have to potentially use deep learning to generalize, but then we would require training over a very large data set, which we avoided following the current process.
Good. That's from my side.
Perfect.
Yeah.
Thank you very much for the questions.
Thank you, sir. We'll be proceeding ahead with our next presenter. I'd like to invite our next presenter, Iroslav, with the paper titled Design of Cluster Computing Architecture to Improve Training Speed of Neuro-Evolution Algorithm. So if you're ready, then you can start your presentation. Do we have the paper presenter here? It seems we do not have him yet. We'll be proceeding with our next paper till then. Azadeen with the paper titled Load Flow of 210. Sorry. Yeah.
Yeah. You hear me?
Yes, sir, you're audible. Please go ahead.
Screen is good.
Yes, sir, it is visible.
Thank you. Hello, everybody. I'm pleased to present my topic today, load flow analysis of 210 megawatt wind farm using ETAP software. Throughout this presentation, will delve into the intricate details of using this powerful software to analyze the electrical dynamics of such as important renewable energy sources. Join me, we explore the complexity of and the insights gained from this innovative approach to understand and optimize the performance of wind energy system. The first step in the project plan is to perform a load flow analysis. The analysis will be run to evaluate the performance of the electric system by ETAP software, and the details wind farm data study will be provided. In ETAP, the load flow will be simulated, taking into account various parameters and scenario related to the operation of wind farm. Finally, the conclusions drawn from the load flow analysis will be summarized. Turkey's axis of load flow analysis are modeling the power system components and network, load flow equations, and numerical technique. Modeling the power system components and network. In this phase, we will explore how to various power system components such as transformer, transmission line, and generator are modeled in ETAP software. This detailed modeling is essential to accurately represent represent the network topology and electrical equipment characteristics. Load flow equations will look at the fundamental load flow equations which mathematically describe the balance and active and reactive power in electric system. This equation finally will look the numerical methods used to solve these equations. Modeling the power system components and network. A bus in power electric system is the vertical line to which the different electric points of the power system is, such as power supply, load, and generators are connected. Buses in the electric power system are related to four quantities. These quantities are reactive power, active power, voltage phase angle, and voltage magnitude. In load flow side, two variables are to be determined, and two variables are known. Depending on the quantity to be specified, buses are classified into three categories: slack bus, generator bus, and load bus. In this table, we look in the slack bus, the active power and the active are in known, and other parameters are known, and the same for generator base and load bus. We have the two parameters now and two parameters in now. The first step in performance of load flow assessment is to form the U-bus admittance using the transmitter line and the transformer input data. The nodal equation of power system network using U-bus can be written as below. Flowing methods are used to solution for load flow problem. Are numerical methods for the solution of load flow equations. Because we are programmed in etap 3 methods: Gauss-Seidel method, Newton-Raphson method, and fast decoupled load flow. The Gauss-Seidel method derives the flow and load flow equations and solves it iteratively. The Newton-Raphson, it's this equation is the abbreviation of the demonstration of this method, numerical method of numerical method solution. Newton-Raphson, the Newton-Raphson method formulates and iteratively solves all the flowing load flow equations. This equation. And fast decoupled load flow is derived from the Newton-Raphson method. Now, the etap software in the etap software, our simulation is carried out in etap software. This software offers a complete solution to all electric problems such as power flow, transit stability, arc, and and short circuit analysis, cable selection, relay coordination, and best possible power flow. The input of the model block, the inputs to the etap are the network components including synchronous generation, induction motor, static load, power transformer, utility grid, protective elements, bus bar, cable, wind turbine. However, this model we ultimately modeled in etap in order to explore and analyze the wind farm power flow, which is one of the software outputs. In this slide, we have the synoptic diagram of wind farm. There are 50 wind turbine of synchronization, which with a production power of 4 megawatt each megawatts. Each grouped either by 5 or 6 turbine. The energy produced by the same of the all of turbine will be fed into the 33 kilovolts bus bar, and two-step up transformer from 33 kilovolts will transmit the energy produced to the power grid. This diagram shows the entire farm programmed in ETAP. There are 15 turbines and all auxiliary installations. In this diagram, we find 5 wind turbines of synchronous generation with a production power of 4 megawatts each that delivers a voltage of 0.69 kilovolts, which will be transformed by specific transformer to each wind turbine to a voltage 33 kilovolts. You will find included the ETAP diagram of the 255 kilovolt substation installation. The energy produced by each wind turbine is transmitted by cable to main bus bar to 30 kilovolts, and the end of transforming this voltage in the transformer station by 2 power transformer. You can find this table from the database of wind farm and is integrated in ETAP. For the simulation, our simulation is capable to calculate current, string, power factor, bus voltage, and reactive and active power for throughout the wind farm system, and gives a complex model of our system. After the simulation of wind farm model, the active and reactive energy flow and the bus bar are shown in each bus of the ETAP synoptic. In this table, for the simulation implementation, the recurrency value and the maximum number of iteration used to compare to the 3 load flow methods are specific in ETAP.
Excuse me, sir. I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Yeah.
Okay.
Yeah.
So I was talking about the time limit, actually. I think you didn't hear me. So can you hear me?
Sorry, I don't hear you.
So I would like to remind you of the time limit.
I can complete the exposition. I can complete the expo.
Yeah, so you can proceed with the summary or the
Oh,
conclusion.
okay.
Okay.
Okay. The results obtained by ETAP simulation of this load flow methods are almost the same. The results are edited by the Newton-Raphson method. The summary of total generation load and demand of the maximum load is present in this table. And the 3 methods is same for the result the results are same. The loss results for the three methods are very close to each other. The table shows the summary ratio of loss transformer Q. And the figure shows amount of overvoltage of 33 kilovolts bus and 0.69 kilovolts bus and overvoltage of wind transformer. This figure represents the percentage of overvoltage of wind farm transformer bus bar 30 kilovolts and 0.69 kilovolt. The critical and marginal voltage drop and overvoltage standard set by the utility and 10% respectively and are not significantly violated. The study of load flow modeling simulation and analysis in 210 megawatts capacity wind farm is implemented using ETAP, a comparison of the command load flow technique, including neutral resistance, fast decoupled, and accept loss and CDL was presented. Numerical load flow methods were linear, compared, and employed to solve the given task. The results of load flow event in ETAP were obtained and analyzed. Thank you.
Okay, good. I think you have concluded. Am I right?
Yeah.
Yeah. Good idea, good concept. Can I have one question? Can I?
Yeah.
Okay. You have presented three methods for simulation work. And what do you think out of these three methods for practical implementation for real result, which will give good results out of these three?
In wind farm, after the study of the wind study and the technical study, we use the ETAP and the other software to verify or develop load flow, and we can help to protection calculation.
Yeah, but there can be
relay and calculate relay and protection.
yeah, but
And
there can be change in
implementation.
yeah. Okay, okay.
Thank you, sir.
Okay, okay. From
Thank
my
you.
side, no question. Thank you.
Thank you.
Thank you, sir. We'll be proceeding with the next presenter.
Thank
I'd
you.
like to invite next paper presenter, Yuri, with the paper titled Multi-Model Metadata Augmentation for Federated Learning in Medical Applications. So if you're ready, then you may start your presentation. Paper presenter, Yuri. It seems we do not have him here yet. We'll be proceeding with the next presenter. Till then, next paper presenter, we have Maria with the paper titled Self-Supervised Learning to Improve Froth Images Segmentation. Ma'am, if you're ready, then you may start your presentation.
Yeah.
Yeah.
Hello, everybody. Okay. Oh, just a moment. Okay, do you see my presentation?
Yeah, it is visible. Please go ahead.
Yeah. Okay, thank you. So, good evening, everybody, the conference participants and commission members. I'm Marina Rumentsova from ITMO University from St. Petersburg, Russia. And our paper is about application of self-learning methods for problem segmentation of rough images. So our work is aimed at creating an approach for semantic segmentation using self-learning technologies due to a small amount of labeled data. So we examine flotation images where presented a large number of homogeneous bubbles, and the bubbles have a similar color, size, shape, and we have three classes of different flow rotations with big bubbles. This class you can see on the image, mixed image, and with the small bubbles. So the needs of the segmentation is due to analysis for technologists. It is necessary to understand the size distribution of bubbles as it is related to the characteristics of the ore dissolved in the foam. So as a problem, I would like to highlight that fact that at the moment creating label datasets for segmentation models is very labor intensive. So it would be optimal to find a method that can provide us high accuracy with a small amount of label data. During the analysis of the related work, I would like to draw attentions to the difference between self-learning and conventional neural network learning. We first use the large amount of unlabeled data from video flotation to train the network and pretext tasks, like a puzzle on this picture. When we will this network into the final one, or simply add new layers at the end, which allow us to solve the main problem with segmentation. This approach allows us to increase the accuracy of models when we have a lot of unlabeled data, but little labeled data. So we examined several different architectures of the pretext data and of the pretext task. And the first architecture for solving pretext problems is about twins. In this task, we take a data set, apply various types of augmentation, and take the same meshes for training, in our case, an encoded format. So watch from which mesh through the position head, we obtain a representation of each object from each mesh and train them so our loss is contacted when difference between them tended to 0 and the read could notice identical objects. So simply, if to simplify, we change different to several images, and our network trains to change the difference, to find the difference, and to restore it to one images. So also to train model to solve pretext tunnel, we need to augment data. In our work, we choose several basic implementations like rotation, some playing with hue and brightness, rotation, the combination of rotation and crop, and to add some kind of margins. So also we use the momentum contrast method. The following architecture also has two networks, but unlike our twins, one network is trained using backpropagation and the other using multiplication with weight of the first. For the downstream task, we chose the unitary architecture because it is designed for segmentation task. And in our case, its architecture is convenient in witnessing vision in the identical encoder and decoder blocks, so we can similarly train the encoder. So also we compared various loss functions like linear cross entropy, and its score turned out to be best because it works well on pieces with large and small bubbles. Also we tested focal loss function, but it doesn't work well with the small ones, and the combination of BCE and dice loss with works badly with the bigger ones. So and finally we choose the linear cross entropy loss to realize the downstream task. So we have several experiments with different pretext tasks, and we will start with one successful experiment. This is the commonly used problem like jigsaw puzzle. So we have an image what we divided into several pieces and rotatory pieces, and the task of the network is to solve this puzzle. So we hope that it will help to learn the some learning representations of images because it's a image of a horse is highly structured, but as a result we get the bad result. As the result, result was bad, so we realized that what it won't help us in our task. So after we continued our experiment using parallel twins and mock architectures, so we compared the results on training on pure UNet and UNet using pretending task with Moco and parallel twins. Images obtained without pretending show what the bubbles match, many bubbles match into one, and the boundaries are highly unclear. So it's only common to see highlights on the bubbles being incredible market as background. And while this can be corrected with person method, it's not correct for our final task. So with pre-training, the quality of recognition improves and the boundaries become cleaner. Also, the boundaries between different bubbles become much thinner than before. So it becomes much more better than without pre-training. Yeah, and the image we find from also we noticed what for example, bubble twins find much more small bubbles than pure UNet, and also more than the mock UNet. Okay. Also, we found the interesting architecture modification of UNet, but used for segmentation medical data with small amount of labeled data. Its name's AKI UNet. And despite the fact that this architecture show good result in medical data, for our task it may serious errors both we found and with pertaining. Without pertaining, it's the obtained result would not allow us to make any conclusion about size distribution, and the situations became better using pertaining, but many bubbles ended up being merged into one, which also reduced performance. Result of the models shows what the optimal choice for predicting bubbles without taking account boundary validation is Moco UNet and taking into account segmentation math accordingly. At the moment, the optimal network is measured on UNet architecture, in which the encoder was initially training the parallel twins network. So for relight the results, we use the intersection of the union metrics, despite the fact that we work with highly balanced data, so we have much more foreground than background. It allows us to make some conclusions, but also we used some kind of visual relations to relate the quality, but you can meet it in our article. Also, we have made some experiments with ultra encoders architecture. So one of these is a Mexican after-encoded, which uses transformers to encode and decode an image. So the pretext task is a construction of a masking image, and image is divided into small parts of 16 to 16 pixels, and the token is generated for each patch, which and when they are shuffled. Some patches are masked, but and the remaining ones go into encoder, and at the output of the encoder, we receive a set of amendments, which we supplement with masked patches, which are fed to input of the decoder. So the result of a pretended model on the protect us show us with the default maximum fraction of 0.75 is not suitable for homogeneous data, so a masked fraction of 0.3 was used. Yeah. And after additional training, image restoration improved and performed well across 4 images, where we maxed out they are specific with structured data, but poorly on fine and medium fine images. For the segmentation task, we took a trained with my encoder with frozen range and added the decoder with randomly initialization with. Binary entropy was used as a loss, and unfortunately, it was not possible to achieve an acceptable result. Most likely, our data with bubbles is too homogeneous, so for encoders, the restoration doesn't reveal length largely. So, as a result of our work, it was concluded that the optimal solution for our task is to use the model based on unit architecture with a mock-up retraining. So as our result, we trained several popular models and choose the best one. So at our moment, the best options to continue our artwork is to modify loss functions to take into account the specifics of our homogeneous data. And our plans continue to work with data in video format because the prof flotation is originally a video, so we can use some features from a video, like maybe information of the bubbles ways, and also we continue to work with masked after corners and hope that it will be give our better results than before. So thank you. That's all from me.
Yeah. Hello, Maria.
Yeah.
Very first, good presentation, depth content, and in-depth research, I can say. I have one question. You have presented my method, VITMAE method. In that, encoding and decoding has been done. While encoding and decoding of images, did you consider any privacy parameter? Did you taken care of privacy of data? In
Sorry,
PPT number 13,
one, three.
page number 13.
Yeah, okay. I didn't
Before
get
this,
it's not
after,
our
after
architecture, it's
this,
yeah. So we didn't modify the origin and architecture. It's was taken from the, as I remember,
yeah,
meta.
good.
Right?
Yeah, yeah.
Yeah. So I still didn't get your question.
Here, while encoder, deciding encoder, and again for decoder, did you consider any privacy parameters? All these inputs are taken care of privacy parameters.
Privacy parameters. I never. So I never heard this term of deep learning. So maybe I just didn't get your question.
Yeah. Practical point of view, we must think over privacy parameter, security as well as privacy.
Yeah.
Here, security is not more applicable, but privacy is applicable.
Okay, maybe we didn't.
Okay, no problem.
Okay, so
Overall,
maybe we
presentation.
can talk about it later. Maybe you can write me questions and we discussed it because so I can't answer it right now. Maybe I just don't. Maybe we have some difference in our terms. We don't use it, but here is my email, and you can write to me, and we will discuss a question.
Yeah, no issue.
Okay,
Okay,
thank you.
thank you. That's it from my side.
Thank you, sir. Thank you, ma'am. We'll be proceeding with our next presenter. I'd like to invite paper presenter Paul to present the paper titled Sensory Substitution in Music, Enhancing Depth Perception Through Vibrotactile Feedback. So if you're ready, then you may start with the presentation. So you aren't audible, I'm afraid. You're not audible, but your slideshow is visible. The PPT is working just fine.
Can you hear me now?
Yeah, you're audible now. Please go ahead.
Okay, cool.
Okay.
Okay, give me a sec. Okay. Hello, my name is Paul Ramache. I'm from Ecuador. I work at Universidad Indoamérica, and I'm also researching for the Universidad of Malaga. And I will present the project Sensory Substitution in Music, Enhancing Depth Perception through Vibrotactile Feedback. In my presentation, I will start with a very short introduction about haptics, and then introduce the topic of musical haptics. Then I will present the methods and tools we used in our research, and then with the most important results and conclusions. Haptics, well, haptics is a quite new research field where you basically try to convey information through the sense of touch. There are two branches of haptics. One is related to the kinesthetic information, and the other with touch. I'm gonna talk about touch, which is related with vibrations and vibrotactile feedback. We can see here a couple of pictures of commercial devices that you can find on the web. One is a very quite big device, which is the best, where you find a lot of vibrotactors or actuators which vibrate and convey information. These are devices usually that you find in virtual environments or virtual devices. And on the right, you can see a more simple representation of vibrotactile feedback through vibrotactors that are placed, in this case, in the wrist and on the arm, and the forearm. And they have fewer vibrotactors, but the information they convey is quite similar. And we are going to use kind of the same actuators in our research. We used these kind of actuators. So in the field of music, some researchers a couple of decades ago found that it is possible to represent music or some musical characteristics through vibrotactile feedback. Here we can see, we can say is a novel device called the hedonic haptic player, designed by Valgarta et al. In 2017. It's quite similar to a Walkman, if you are familiar with the Walkman or these iPod devices that play music. This device was designed to offer vibrotactile feedback instead of sound, so that you can feel the vibrations of music instead of sound through the ear. This device was tested in deaf people with hearing impairment, and other we were not deaf people, and the results were very, very interesting of this kind of nice device. It's not commercial, but it's under research. So what is our approach? The problem with vibrotactile feedback, and specifically with music, is that we usually hear sounds in a frequency range, in a quite wide frequency range, which is from 20 hertz up to 20,000 hertz. But when we touch vibrations, when we convey vibrations through the sense of touch or through the skin, we can only feel vibrations from approximately 3 hertz up to 1,000 hertz. So when we render the music, which is designed for the ear, to vibrations, a lot of information is lost. So because of this limitation of the frequency range that we can feel through the skin, what we propose is to do something like we can see here in the image. This picture shows that we have an audio file. We have an audio file which has the whole frequency range that we can hear from 20 to 20,000 hertz. To compress it and bring it to a more limited frequency range, which is in the range that we can actually feel. And what we use here is a sinusoidal modeling. So this is the method that we proposed, as we can see here in the flow chart. We start with a monophonic audio file, which means that it has just only one channel or one signal. And then we apply a sinusoidal modeling that I will explain later. And then we add some effects. Then we use the head-related transfer function to create to specialize the sound. And then we convert it to stereo audio. Then we perform again this splitting to left and right channels to have two actuators like a stereo audio. And then we apply again the sinusoidal modeling to ensure that the signal is actually between the frequency range that we can actually feel. We merge the audio channels and generate a stereo file that is amplified and sent to the actuators. And finally, we test the vibratactors if they work or not, generating psychophysical sensations in some participants. The audio file we used in this pilot test, because it was like a pilot experiment we did with our approach. We used an audio file where we recorded a jazz player playing saxophone, because the saxophone has a very rich texture and usually covers a very wide range of frequencies, especially those that are in the frequency range that we can actually feel. So the work is going to be easier. For this pilot test, it was important to choose a very wide frequency range instrument and a simple song, which was a jazz song. So we kept this simple because we were starting with this algorithm with our approach. So here we have what we use to compress the frequency range of our audio file. We use the modeling, the musical sound modeling with sinusoid plus noise article of Sarah. Sarah is a researcher here in Ecuador that works at Universidad San Francisco de Quito, and he's an expert at processing audio signals. And his idea was to compress the frequency range or the spectrum on the frequency range of the audio file and bring it to a lower, a more quite, let's say, a more adequate frequency range for the skin. We can see here in the table the sum of the variables that we controlled and the values we assigned. We can see there is the sampling rate, the window size, window hop size, etc. We can check that in our paper, and you can also check the paper of Sarah, where is the actual algorithm to generate this sinusoidal modeling. And the audio effects, we can see here the audio effects we applied. We used the harmonizer, which is a kind of chorus effect that music producers usually add to the instruments when they are mixing and producing music. And also we used the vibrato tremolo effect. And we represented this with W0 to the file that has no effects, with W7 the audio with harmonizer, and W12 with vibrato tremolo. For our experimental design, we had 10 non-deaf university students, 5 females and 5 males, aged from 18 to 23 years old with a mean of 20 and a standard deviation of 1.69. Each participant used 2 vibrotactile actuators on their arms, with the arms resting on a flat surface. The participants were also blindfolded and isolated from external sensory stimuli in a controlled environment. This was important because the participants had to be focused on the vibrotactile feedback generated by the audio files. So we tried to make it a very, very controlled environment. The participants were presented the 3 audio files, the one with no effects, the W0, the harmonized with the W7, and the one, yeah.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Yeah, okay, yeah, no worries. I'm almost done. And the one with W12, the one with vibrato tremolo. For each file, participants rated the quality of the vibrations from 0 to 7. And here is the interface. We just used an Arduino Duo with a module HR01040F to read the audio files from an SD card and an amplifier to amplify the signals to send to actuators left and right. Here we have the results. The one on the left is the original audio file, the spectrum of the frequency spectrum of the audio file original. And on the right, you can see the compressed signal sent to the actuators. Here are the ratings of the audio files, and here you can see that the audio files processed with the effects W7 and W12 are the best rated. Specifically, W12 is the best. And the psychophysical sensations the participants reported were kind of movements, spinnings, and some kind of effects like tactile illusions that are similar to auditory illusions. Our conclusions are that after conducting our experiments, we generated files capable of effectively transmitting vibrotactile sensations. The psychophysical sensations such as motion and rotation can be discernible, with the vibrato tremolo effect standing out. The sinusoidal modeling and the spatialization of the signal can be used as an effective method for haptic music players that offers an alternative to perceive music through the sense of touch. And finally, we recommend to replicate our experiment with hearing impaired participants to compare the perceived sensations. And in the future, we plan to include more instruments in the audio file and vary the genres to find out if the perception of vibrations and the psychophysical sensations change. Thanks so much. If you have any questions or you want to collaborate, please stay in touch. There's my email. You can contact me. Thank you.
Paul, good presentation and interesting topic.
Thanks.
I have only one question. In experimentation, how did you measure the frequency? That is,
well, we
while
actually
there-
did not
there is
measure the frequency.
Yeah.
Yep. You asked
Yeah.
if we measure the frequency.
Yeah.
Well, it was not possible for us to measure because we didn't have any instrumentation to do that. But before sending the audio files to the amplifiers and actually saving to the SD card, the files were tested in the computer. So we represented the, if you can see here, we represented the spectrum, the frequency. You can see here how the frequency was compressed, but the peak frequencies were kept in each of the files. So this was run before sending the files to the amplifiers. So, and actually you can feel, you can actually test them physically. If you play the audio file without the sinusoidal modeling, you can feel that the frequencies are wider. But when you test the files after the sinusoidal modeling and after the effects, you can feel that the frequencies are more compressed. You can actually feel that. And probably we we need to test that in the future. I mean, measuring the frequencies or showing them somehow in an interface. But yeah, thanks for your question. I think that's something important we will take into account for our future research. Thanks.
Okay, good. That's it from my side. Thank you.
Thank you.
Thank you, sir. We'll be proceeding ahead with our next presenter. I'd like to invite our next presenter, Emmanuel, with the paper titled Terraria AI, YOLO Interface for Decision-Making Algorithms. So if you're here, then you may start with the presentation.
I'm sharing. Can you wait? I would like to see what I'm sharing.
Yeah, it is visible.
Also-
Please go ahead.
Okay. Okay. Let me, since I have to move the camera, let me move sorry, I have to move the screen. I will move the camera as well. Good afternoon, everybody. My name is Manuel Barrantes. I'm from Costa Rica, Tecnológico de Costa Rica. I'm going to present you this topic, Terraria AI, a YOLO interface for decision-making algorithms. General artificial intelligence is that intelligence which can equal or exceed the average human intelligence. This is why research has been carried out in the fields of image detection, sound interpretation, toys, aviation, and so on. The field of study that interests us is video games, which has made many contributions to this science. This is the agenda for today. I'll give a short introduction and some examples of the related work, then the approach of the experiment, then the design of that experiment. I will explain the results, and finally the conclusions and future work. Since its beginning, video games have been a means to assess the capabilities of artificial intelligence, leading to significant advancements such as specific algorithms for Go and chess. Competitions in artificial intelligence drive the development and application of new algorithms. One important competition is the general video game artificial intelligence, which uses a video game description language. However, there are limitations when using a video game description language, as not all the games can be accurately described with it. In this research, experimentation was conducted with Terraria. It's a video game. We aim to utilize the screen as an input for this artificial intelligence research. The proposal involved using YOLO, or you only look once. This is a revolutionary approach in object detection that uses a single convolutionary network to predict bounding boxes and their class probability simultaneously. Unlike other methods, YOLO consider the entire image, optimizing both the training phase and the detection. The video game description language is in that competition that I mentioned before. Is a language that is used to describe video games. A game described or that uses this language consists of two files: game description and a level description. Both are text files that contain information about the game. The one that was used for this research was the level description. That's the one that is shown in the image. The Monte Carlo tree search technique, or MCTS, is a search method based on Monte Carlo. MCTS employs stochastic simulations to make decisions about moves. The process consists of 4 steps: selection, expansion, simulation, and backpropagation. Evolutionary algorithms are techniques inspired by biological processes such as reproduction, mutation, and selection. These algorithms, combined with simulators, are employed in controllers for research in artificial intelligence. One of the planning approaches that was used in this research is the rolling horizon planning, where an agent plans based on a limited view of the game. Terraria is a 2D, two-dimension sandbox game where maps are randomly generated from a seed. The game focuses on three main activities: combat, where you face monsters; resource extraction, where the player obtains material by excavating; and construction, where tools, weapons, armor are crafted using the collected materials. As seen in the figure on the right, where a wooden armor was built. To achieve this, one needs to cut down trees, gather wood, build a workbench. Reaching this point, constructing a workbench, is considered the ultimate goal for the agents in this experiment. Some related work, there is a research called Mind Dojo. It's a platform designed to drive artificial intelligence research within the game of Minecraft. This game it has three-dimensional world with a wide range of trains and tools. Does not have pre-established objectives, as well as is similar to Terraria. Although the YOLO technique has been widely used in researches for real-time object detection, I couldn't find any application in video games. Some notable application of YOLO is the verification of proper use of hard hats on construction sites to ensure safety. For this research, we use a multi-factor experiment, which is designed to analyze the impact of several factors at multiple levels. A factor is an element which with different levels that influence what you are measuring. And on the other hand, analysis of variance, or ANOVA, is a statistical technique used to evaluate whether there is a significant difference between the average of various groups. ANOVA was used to analyze the data from this multi-factor experiment. For this study, the factors and their levels are shown in this table. Decision-making algorithm is one factor. It has two levels: Monte Carlo tree search and rolling horizon evolutionary algorithm. The map seed is another factor, defines the gain configuration. We selected 8 randomly generated seeds. The third factor is the decision time. It refers to the time the agent has to make a decision. In this case, it has two levels, 2 seconds and 3 seconds. The response variable, or what you want to measure, is the time to target, which means how long it takes an agent to create the workbench from the start of the game. The architecture for this intelligent agent consists of 4 components that simulate the cognitive and motor skills of an intelligent entity. The first one is the YOLO model, which would be like the eyes of the agent, interpreting and understanding the environment. The second one is the forward model. This will be part of the agent's. It could be seen like part of the agent's brain, allowing the agent to anticipate and simulate future scenarios based on past actions. Decision-making algorithm, it could be seen as the other part of the agent's brain, evaluates and chooses the best action based on the predictions of the forward model. And the environment. Once an action is decided, the environment takes over and execute that action, similar to how hands would work. Training the YOLO model presents challenges such as get a suitable set of images, right, a data set, and above all, labeling those images accurately. Image labeling consists of enclosing all the objects of interest in a rectangle. For example, in this image, the tree is enclosed in a rectangle, and it is specified that this rectangle has a tree. This needs to be done for each object of interest in the image. No object can be left unlabeled, as this seriously affects the accuracy of the model. Manual labeling of these 9 classes that were used for this experiment are shown in the table. It took 9 months, a little over 8,000 rectangles or labels. For this research, YOLO 5 was used. once the model was trained, a MIP of 0.99 was obtained. The MIP is a metric that it is used in computer vision and indicates how accurate the model is. The figure shows the confusion matrix of the model. This matrix says how much the model confuses one object with another. The forward model is used in the simulation phase for the Monte Carlo tree search algorithm and the rollout phase for the rolling horizon. Its main functions include providing the current state of the game, composed of two matrices. One defines the elements of the screen and the other the player's inventory. Lists the possible actions in a given state. Also identifies if a state is terminal and simulates an action. This this simulation is done based on a current state and generated a new post-action state. The decision-making algorithms start with a state generated by the YOLO model and simulate the game using the forward model to determine the best action based on the expected reward. Once an action is decided, that action is sent to the game environment. This one
Really
takes
sorry
the
to
action.
disturb you. I'd like to remind you of the time limit.
Thank you. The game environment takes the action and executes it, then takes a screenshot and sends it back to the decision-making algorithm, and finally checks if the player has already completed the workbench. In this image, we can see the agent completing the objective. This is an example. In this case, it was using rolling horizon, and this is an example of the agent completing the objective. But this was not only achieved on this example; it was also achieved for the rest of the runs or experiments, achieving a 100% success rate. This is the table with the ANOVA results. As we can see here, only the factors have a statistically significant difference. Therefore, only we do a post hoc analysis of those three factors. This is the post hoc. For this, we use the graphs of average and error bars. The figure shows the average time that it took for the agents based on the algorithms. As we can see, the RHEA, rolling horizon, was better than the MCTS. Here, the average time, but based in the seats. As we can see, the number 2 seat was the more hard or difficult, and the easiest one was the number 5. In this one, we can see that the as we have more time to make a decision, we get worse results. As we can see here, we achieve worse results when using 3 seconds for the decision-making algorithm. In conclusion, once YOLO was trained, a very accurate model was obtained with an MIP of 0.99. Rolling Horizon has better performance than Monte Carlo. It was discovered that the longer the decision time, the worse the performance. Labeling was the most time-consuming task for the research, and YOLO was shown to be viable method for using agents in open-ended video games. For future research, we plan to integrate reinforcement learning techniques instead of using decision-making algorithms. We seek to expand the scope, maybe not just build a workbench, going even further in the game. We want to combine performance learning techniques and decision-making algorithms, and also try this method with other video games. Thanks, that would be it. I thank you very much for your attention, and now I'll try to answer any questions, queries, or comments.
Okay, good. As a summary, your model is accurate and your algorithm is giving a good performance. Over there, I have one question. Evaluational algorithm, if you see, gives a approximate result. So that do you have any justification? You have compared your evaluationary with some existing algorithm, so that
Can you repeat the question? Sorry, I kind of lost one part. the question.
Okay, in short, evolutionary algorithms gives approximate result. Do you agree?
Approximate, why approximately?
Exact result, exact in your game, exact move can we get through this evolutionary approach using this approach? You get exact move or approximate move.
Approximate moves, you mean? Sorry, I couldn't hear that part. Can you
Okay,
repeat it
in
again?
short,
Sorry, I can.
in short, your algorithm gives you exact result or approximate result.
The result we measure as the agent was able to create the workbench, so it was more a matter of it was able or not. So it was not quantification results. It was more like a the agents were able to do it or not. So we don't have any approximations for the results. Is that what you meant? Or I'm missing the question again?
Okay, no issue. That's it from my side. Okay.
Thank you for your question.
Thank you, sir. Since we do not have our last two presenters for the session, this brings us to the closing. I sincerely thank our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICICT 2024. I'd also like to thank our session chair, a token of appreciation on behalf of Team ICICT and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you.
So you're on mute.
Yeah. Sorry. Thank you, ma'am. Thank you.
Thank you, sir. I'd like for everyone to turn on the cameras for a quick snapshot of the virtual conference.
Can you also send me that screenshot, maybe? I don't know, sharing. I don't know how, maybe send it by here, by Zoom. I would like to have it.
Screenshots?
Yeah.
Yeah, sure. You can put your mail ID in the chat box and then I'll share them with you.
Okay.
Thank you, everyone.
Thank you.